Hello students, welcome to the Student Support Program for Additional Mathematics for grades 10 and 11. We are going to look at the application of differentiation. So in today's lesson, you will learn how to apply differentiation to maxima and minima problems. The prior knowledge for today's lesson, so you need to remember how to differentiate a given function. You need to know your product rule, your quotient rule, minimum and maximum points, which you have already learned in the previous lesson. Here you can make use of the first and second derivative tests to discriminate between maxima and minima. You also need to recall the chapter circular measure and to know the formula for the surface area and volume of 3D shapes. So let us start. You will recall that in the previous lesson you have learned how to find maximum and minimum points. A quick recall. So given y equal to f of x, you need to find dy by dx. Then you need to find the turning points. Now remember, for turning points, dy by dx is equal to 0. You then find the corresponding values of x by solving the equation dy by dx equal to 0. And then you need to determine the nature of the turning points using the different methods. You can either use the sign test or the second derivative test. We are going to use these steps in the following examples. So let us start with example 1. In this question, all the lengths are in centimeters. A closed cylinder has base radius r, height h, and volume v. It is given that the total surface area of the cylinder is 600 pi and that v, r, and h can vary. First part, you need to show that v is equal to 300 pi r minus pi r cube. Second part, you need to find the stationary value of v and you need to determine its nature. So, remember, you have been given that the total surface area of the cylinder is 600 pi. Now, it is a closed cylinder. Do you still remember the formula for total surface area of cylinder? So you have two circles, one at the top, one at the bottom, and you have a curved surface part. The formula will be 2 pi r square for the two circles and 2 pi r h for the curved surface area. So the total surface area will be 2 pi r square plus 2 pi r h equal to 600 pi. So here I'm going to make h subject of formula. I will have 2 pi r h equal to 600 pi minus 2 pi r square. H will be equal to 600 pi minus 2 pi r square over 2 pi r. Simplifying, I'm going to cancel the 2 pi and this will give me h equal to 300 minus r square over r. Now, what is the formula for volume of cylinder? Do you still remember? So volume of cylinder is pi r square h. Now, I'm going to replace the h here by the expression which I have obtained above. So volume V will be given by pi r square. The h is 300 minus r square over r. Simplifying, I will obtain pi r into 300 minus r square, and expanding the brackets will give me V equal to 300 pi r minus pi r cube. And this was what I was asked to show. Now the second part. So using V equal to 300 pi r minus pi r cube, I need to find dv by dr. So I differentiate v. I obtain 300 pi minus 3 pi r square. Now for the stationary value of v, dv by dr will be equal to 0. So I equate this expression to 0. And I need to solve for r. I divide by 3 pi. I obtain 100 minus r square equal to 0. R square equal to 100 and r will be equal to 10. Note, here I'm taking the positive square root because r is the radius and radius cannot be negative. So r equal to 10. Now I replace this value of 10 into the expression for v above. So v is going to be equal to 2000 pi. Now I need to determine the nature. So d2v over dr2 will be equal to minus 6 pi r. I have differentiated dv by dr again, and replacing the value of r equal to 10 will give me d2v over dr2 as a negative value. That is, it is less than 0. So the stationary value of v is 2000 pi and it is a maximum. Maximum because I have obtained a negative value. Now we move on to example 2. So the diagram shows a badge made of thin sheet metal consisting of two semicircular pieces. So you can see here we have two semicircles, centers B and C, each of radius x centimeters. They are attached to each other by a rectangular piece of thin metal sheet ABCD, such that AB and CD are the radii of the semicircular pieces, and you are also given that AD equal to BC equal to y centimeters. Part A, given that the area of the badge is 20 centimeters square, show that the perimeter P centimeters of the badge is given by P equal to 2x plus 40 over x. Part B, given that x can vary, find the minimum value of P, justifying that this value is a minimum. Remember, for minimum, we are going to have d2p by dx square greater than 0. So part A, we have been given that the area of the badge is 20 centimeters square. Now the radius was given as x, so the area will consist of the two semicircles plus the area of the rectangle. So I have two semicircles and this rectangle, which will consist of the area of the badge, which is equal to 20 centimeters square. Remember, area of circle is pi r square. So combining these two semicircles, I will obtain a full circle, pi r square. So here my radius is x. I will have pi x square. And I have a rectangle of length x and width y. So pi x square plus xy equal to 20 centimeters square. So here I will make y subject of formula. I get xy equal to 20 minus pi x square. Y will be equal to 20 minus pi x square over x. Now I need to find the perimeter of the badge. So the perimeter will consist of the circumference of the circle. I'm going to take the arc AE plus DF, which will give me the circumference of a full circle, plus AD plus CF plus BC plus BE. I repeat, we take the semicircle here, AE, plus DF, which will give me the circumference of the circle, plus AD plus CF plus BC plus BE. So the perimeter will be 2 pi x for the circumference, plus y for AD, plus x for CF, plus x for BC, plus y, which will give me 2 pi x plus 2x plus 2y. So the perimeter now, I'm going to replace the y by the expression which we have obtained earlier. So 2 pi x plus 2x plus 2 into 20 minus pi x squared over x. And simplifying, I obtain 2 pi x plus 2x plus 40 over x minus 2 pi x. 2 pi x will cancel with 2 pi x. Finally, the perimeter will be 2x plus 40 over x. And this was what I was asked to show. Now, the second part, I need to find the derivative of this expression. So P equal to 2x plus 40 over x. This can be written as 2x plus 40 x to the power of minus 1. Now differentiating this, dp by dx will give me, differentiating 2x gives me 2. Now differentiating 40 x power minus 1, so bring down power, decrease the power by 1, minus 1, which is minus 2. Rewriting it, I get 2 minus 40 over x squared. Now I equate it to 0 to find the minimum value. So when dp by dx equal to 0, this means 2 minus 40 over x squared equal to 0. Multiplying throughout by x squared, I get 2x squared minus 40 equal to 0. X squared equal to 20. And x will be equal to square root of 20. So using your knowledge of surds, I simplify and I obtain 2 square root of 5. Now I replace this value of x into the expression for p. So p is going to be equal to 2 times 2 square root of 5 plus 40 over 2 square root of 5. So simplifying and rationalizing, I will obtain p equal to 8 square root 5. So now I need to find out whether p is a maximum or a minimum. So dp by dx was 2 minus 40 x power minus 2. Now I need to find d2p over dx2. So differentiating 2, I get 0. Now differentiating this part, bring down the power. So minus 2 times minus 40 will give me 80. And decrease the power by 1. Minus 2 minus 1 is minus 3. So I get d2p over dx2 equal to 80 over x cubed. I replace the value of x which I have obtained earlier. That is x equal to 2 square root of 5. I replace into d2p by dx2 and I obtain a positive value, which means that p is a minimum. Now we move on to example 3. The diagram shows the sector OPQ of a circle, center O, radius r centimeters, where angle POQ is equal to theta radians. The perimeter of the sector is 10 centimeters. First part, show that the area, a centimeter square, of the sector is given by a equal to 50 theta over 2 plus theta to the square. Now, it is given that theta can vary and a has a maximum value. Second part, you need to find the maximum value of a. So here, you have been given the perimeter of the sector as 10. And if you look in first part, you will see that there is no R in the expression for A. So this is going to give you an indication that you have to make R subject of formula. So let us start. Perimeter of sector is going to be R plus R plus R theta. Remember the length of arc PQ is R theta. So R plus R theta equal to 10. This gives me 2R plus R theta equal to 10. I factorize R into 2 plus theta equal to 10. And R will be equal to 10 over 2 plus theta. Now, I need to find the area of the sector. So the formula for area of sector is half R square theta. And I replace the expression which I had obtained for R into half R square theta. So A is going to be equal to half into 10 over 2 plus theta to the square times theta, which gives me half times 100 over 2 plus theta to the square times theta. Simplifying, I obtain 50 theta over 2 plus theta to the square. And this was what was asked to be shown. So here I need to find dA by d theta, and I will be using the quotient rule. So U equal to 50 theta, du by d theta will be equal to 50. V will be equal to 2 plus theta to the square. So dV by d theta will be bring down power, decrease power by 1, times the derivative of a bracket, which is 1. So I obtain dV by d theta equal to 2 into 2 plus theta. Now, dA by d theta. Remember the quotient rule. The formula is V du by dx minus U dV by dx over V square. So V, 2 plus theta to the square, times du by d theta, which is 50, minus U, which is 50 theta, times dV by d theta, which is 2 into 2 plus theta, over V square. So here, V is 2 plus theta to the square. Therefore, V square will be 2 plus theta to the power of 4. Expanding the brackets and simplifying, I get dA by d theta equal to 200 plus 200 theta plus 50 theta square minus 200 theta minus 100 theta square over 2 plus theta to the power of 4. Simplifying, I get dA by d theta equal to 200 minus 50 theta square over 2 plus theta to the power of 4. Now for maximum value, dA by d theta will be equal to 0. That is, I equate the expression obtained previously to 0. This will give me 200 minus 50 theta square equal to 0. So 50 theta square equal to 200. Theta square will be equal to 4. Therefore, theta will be equal to 2. Now I replace the value of theta into the expression obtained for A. So A will be equal to 25 over 4. This is the maximum value of A. You now have some exercises to practice on what you have just learned about maximum and minimum problems. The second question, you have a pair of concentric circles. So you have to be careful here. You're given the perimeter of a shaded region and you will have to find the area. The third question, you have an open container. So when you're going to calculate the surface area, bear in mind that this is an open cuboid. Number 6, you have to find the area of trapezium. So the formula for area of a trapezium will be half sum of parallel sides times height. You now have some interesting links which you could visit to get additional information on how to solve maximum and minimum problems. So students, we have reached the end of today's lesson on maximum and minimum problems. I would advise you to practice the questions found in your textbook, and until we meet again, it's goodbye from me.